Okay, more density problems here. Now we know that density is equal to mass divided by volume. So therefore we also know that mass is equal to density times volume. And then we know that volume is equal to mass divided by density. Now in this case we're looking for the volume. So we know that volume is going to equal the mass divided by the density, so it's going to be 275 grams for the mass. The density, we're not given the density, we're given a specific gravity. And what we know about specific gravity is it's equal to density divided by the density of water. So the density of the object divided by the density of water. So if we wanted to figure out what the density would be, it would be specific gravity times 1 gram per mil. So we got 1.86 as being the specific gravity, which makes the density 1.86 grams per mil. So you can see that's going to cancel, that's going to cancel. We're going to be left with mils on the bottom. So we've essentially got 1 divided by 1 over mils, which is equal to milliliters. So our final unit here will be milliliters, and that's how we get our answer. The number of significant figures, we've got 3 sig figs here, 3 sig figs here, so our answer is going to be 3 sig figs as well. So that's why it comes out to 148. Alright, looking at the next one, we're looking for the mass, and mass is equal to density times volume. The density is given as 13.6 grams per mil. The volume is 500.0 mils. Now in our calculator it's going to come out to be 6,800 grams. Now that's not really a very good answer because we don't know how many significant figures it has. So what we're going to have to do is figure out the number of significant figures we need. We've got 3 sig figs here and 4 here, so we need 3 sig figs, which is why we would convert this into an exponential expression. It would be 6.80 times 10 to the 3 grams. So that makes that 0 significant, but in here you can't tell that that 0 is significant, so this is the better answer, 6.80 times 10 to the power of 3 grams. Alright, looking at the next one, we've got what is the density of a solid weighing this much and occupying 110 mils. So we know that density is equal to mass divided by volume, and the volume here is 110 mils, and that's okay. The density needs to be in grams per mil, but we have kilograms up here, so we'll need to do a conversion. So it'll be 3.00 kilograms, and kilograms goes on the bottom, kilograms goes on top, 1,000 grams over 1 kilogram, so it would be 3.00 times 10 to the 3 grams if we're going to keep the significant figures in the same. So we've got 3 here, and now we've got 3 up here as well. And that's going to give me a final answer of 27 grams per mil. The number of significant figures, we've got 3 in 3.00, but we've only got 2 in 110 mils. Note this 0 here is not significant because there's no decimal point after the 0. So we're looking at 110 as being the number here, 110 milliliters. So we end up with 2 significant figures at the end.